When talking about probability of an event, we can classify some events as possible, certain, or impossible. Possible events have a probability that can be expressed as a fraction, as a decimal, or as a percent. When the probability of an event is 0, that means that the event is impossible, so it cannot happen. It never happens. When the probability of an event is 100%, or as a decimal 1, that event is certain. So a certain event, remember, is an event that happens all the time, that always happens. Some other possible events have a probability that can vary from 0% to 100, including 0 and including 1. So we can get the probability of such events by comparing the number of favorable outcomes to the number of possible outcomes. For example, if I have a number q and I have in my list of possible outcomes or sample space 1, 2, 3, 4, 5, and 6, I have that all the possible outcomes are 6 possibilities. Now, it depends on the event that I want to analyze to get the probability. For example, if I want to get on a number q the probability to get a number less than 4. So out of the possible outcomes that are 6, as we saw before, how many of those 6 are less than 4? So 4 doesn't apply because the condition here says less than, not equal to. So we have that those numbers that satisfy the condition are 3, 2, and 1. And these ones are 3 favorable outcomes. If we rewrite this fraction as a fraction in lowest terms, we'll find that that one is 1/2. As a decimal is 5/10, and as a percent would be 50%. Those ones, or these ones, are simple or single events. If I toss a coin, so here I have to say that the number q is tossed only one time, right? One time. Now, if I toss a coin one time, I can get some possible outcome, possible results, some certain events, or some impossible events. For example, if I want to get the probability of getting heads, only one time, I mean, I'm going to toss the coin only one time, the probability of getting heads, so this one, would be 1 that is favorable out of the 2 possibilities, heads or tails. So again here, the possibility, or the probability, better, is 5/10 or 50%. How can I get an impossible event out of tossing a coin? For example, I cannot get heads and tails at the same time. So if I want to get the probability of heads and tails, this conjunction and means at the same time, right? So this is 0 out of the 2 possibilities, because that one, that event of getting heads and tails at the same time is impossible. So remember that this is an impossible event in which the probability is 0, or as a decimal 0, as a fraction 0 out of the 2 possibilities. So in this case I cannot get heads and tails at the same time. For example, in this spinner, I want to get the probability. So this spinner has in the sample space only 3 colors. It is divided into 4 equal sections, but the possible outcomes or results are only 3. If you can take a look at here, blue, yellow, and orange. Only 3 are my possible outcomes in the sample space. Here, for example, if I want to get the probability of getting orange in this specific spinner, I know that 2 out of 4 sections are orange. So 2 are favorable outcomes for orange out of the 4 that I have as possible outcomes. So again, here, this is just a coincidence. So here I have that this one in lowest terms is 1/2, again 5/10 as a decimal and 50%. Here, in this case, I can also get an impossible event. For example, get blue and yellow at the same time. Blue and yellow. That's impossible, so the probability is 0 out of the 3 possible results or outcomes in my sample space. As a decimal would be 0, as a percent would be 0%. For this spinner that has a different combination of colors, the possible outcomes in the sample space are yellow, black, red, and blue. It doesn't matter that the yellow repeats, but the possible outcomes when you spin this spinner are only those 4 that are in the sample space. Now, if we want to count the possible results of a compound event, those are single events or simple events, simple experiments. Now, suppose I'm going to toss the coin, and after that, I'm going to toss the number cube. Here, this one has only 2 possible results, and this one has 6. If I use a tree diagram, for example, I can start with heads once, heads 2, heads 3, heads 4, heads 5, heads 6. And then the other 6 possible results would be tails with 1, tails with 2, tails with 3, tails with 4, tails with 5, and tails with 6. As you can see, and using the counting principle, the multiplication principle of counting, if this event or if this experiment happens in 2 ways, and this one happens in 6 different ways, the combination of the 2 is 2 times 6. So there you can see that organizing the data, we can get 12 possible outcomes. Now, we toss, for example, the number cube twice. For the first result, for the first time you toss the coin, you're going to get 6 possible results. So you will get 1, 2, 3, 4, 5 until 6. And the second time you toss the number cube, you will get another 6 results. If you combine using the multiplication principle, you will get that 6 times 6 would lead you to a result to 36 possible results in the sample space of what experiment? Tossing the number cube 2 times, or which is equivalent to toss 2 number cubes, and at the end you will get exactly the same sample space. In this example here, I'm going to get some letters. Here, as you can see, they are not repeated. Here I have E, F, G, D, C, B, and A. So out of 7 possibilities, the experiment consists of drawing a card with a letter without looking. So I'm selecting the result at random. I don't know exactly what the result is going to be. So I'm going to select any letter. In this case, the possibility or the probability of each letter, since they don't repeat, is 1 out of 7. 1 out of 7, since I only have 1 A, 1 E, 1 F, 1 G, 1 D, 1 C, and 1 B. If I want to do the same experiment, but this time with colors, so I have that black, 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 and here I have 2 that are red and 1 that is blue. So if I ask you, for example, what's the probability as a fraction to get black, out of the 7 possible outcomes, 4 are favorable. So I would express that as 4 out of 7. The probability to get red, in this case, would be 2 out of 2 that are favorable for red, and 7 out of the possible outcomes. I have 7 possible outcomes here, and 2 out of them are red. If I ask you the probability to get blue, it'll be only 1 out of the 7 possible results. So only 1 is favorable. And then you can convert those fractions into decimals and then into percents. As simple as that. So for example, in this case, one more example of compound events. I'm going to toss this coin 1 time, and I'm going to spin this spinner 1 time. So here, I have 2 possible results, 2 possible outcomes. And here I have 3. So I will go like heads yellow, heads orange, heads blue. And the other 3 would be tails yellow, tails orange, and tails blue. Since orange repeats, the combination of possible outcomes in this sample space would be 2 times 3. If I do this one, for example, this one has 4 possible outcomes. Times 3, we would get 12. And then you can organize those data into a table, and you can see those results also in a tree diagram. For example, I'm going to toss a coin twice. So the first time I toss the coin, this is the first time, I have 2 possibilities, heads or tails. The second time I toss the coin, so let's suppose I got heads on the first attempt. On the second I have 2 possibilities, so I can get either heads or tails. Remember, heads and tails can be gotten at the same time. Suppose I got in the first tails. So the second time I toss the coin, I will get again heads and tails. So here you can see how a tree diagram would look like. Then I can put this information. So coin 1, coin first time, and coin second time. So here we have a tree diagram. Now we have a table. So I can organize this data. The first possible outcome is heads, heads. The second would be heads, tails. The other would be tails, heads. And finally, tails, tails. And using the multiplication principle, MP, multiplication principle, I would say that the first time I toss a coin, it happens in 2 different ways. Times the second time I toss the coin, it happens in 2 different ways. So the probability here, or the possible results, the possible outcomes would be 4. In this case, if I combine, for example, 1 coin and a number cube twice, I have 2 times 6, 12, and times 6 for the second time, 72 possible outcomes. As you can see, when organizing data, either on a tree diagram or a table, the easiest way to get the results in advance is to use the multiplication principle, so I can see how many possible outcomes I can get. And of course, then I can calculate the probability of an event depending on the favorable outcomes compared to the possible outcomes. So don't forget to pay attention in class, do homework, and check the blog.